All right, let's do this one badly. Let's use binding energy per nucleon, right? So let's write the reaction out. We got 197.79, that's gold, right? And then we've got 4,2 helium, right? Remember, an alpha particle, we just use helium, right? Deuterium, we've got 2,1 hydrogen, right? And then here we've got 199.80 mercury, right? Okay. Now, in terms of binding energy, this is per nucleon. So we're going to go 197 of these guys, right? Times, and then this is our binding energy per nucleon for gold. 197 is 7.915744, right? And then we have 4 nucleons here. Right here we had 197. We have 4. Remember, this is per nucleon, right? 4 times 7.073918. Okay. Turns into, let's see, deuterium. Not a lot of binding energy. Not too hard to break up deuterium, right? 1.112287. And there's 2 of those, right? Should have put the 2 before that, but I'll put it after. I'll do it for this one too after, right? And then mercury is 7.905368, right? And there's 199 of those. I can't even read my own writing. 199. Right, so let's figure out the total binding energy here. Okay, let's just do that. 197 times 7.915744 plus 4 times 7.073918. The total energy, binding energy on this side. Remember, this isn't energy you have. This is how far down in the hole we are. 69724 MeV, right? That's the left side. Let's look at the right side. So let's calculate this for the right side. So let's go 2 times 1.112287 plus 7.905368. All right, times 199. So this total binding energy is 1575.39, yeah, MeV. So now let's just subtract. Notice that we went from tightly bound to less tightly bound, right? So this is actually going to require energy, right? If you go to less tightly bound, it requires energy to do that, right? This one's farther down in the hole. These really are negative potentials, right? Okay, so let's subtract this. Let's go this guy minus this guy. And I got 12.3 MeV, right? Okay, and it's endothermic because we went from tightly bound, which is low, remember that's low potential energy, to less tightly bound. This is less tightly bound. That number is smaller. Okay, less tightly bound, right? This is a higher potential energy. Higher potential energy, right? So it would require an energy input, which is exactly what we got using it, the way you actually do it with the masses of the atoms. Okay, so this is just another way to do it.